In this video, we're going to be designing a set of canards for a car, so stay tuned. Hey everyone, this is Matt with Learn Everything About Design, and in this video, I've been asked to show how to design canards for a car. Now, this comment has come in a few times, and it's just something I haven't really gotten a chance to do yet. But in this video, we're going to tackle it finally once and for all. And if you want to follow along, you can download the scan that you see on the screen by going to the description of the video and downloading that data set. This was a scan that we did for the Starion widebody series, which I do have to apologize is not done yet. I just haven't had the time to finalize all of the 3D prints together and sand them and do all that stuff. I have them all printed out. I just haven't had an opportunity or the chance to kind of take care of that. Unfortunately, I had a bit of a mountain bike accident and hurt my shoulder about 2 months ago, and I just haven't been able to do the sanding and all that kind of stuff. So with that said, let's get into taking care of how to design canards. Now, if you don't know what canards are, they are essentially little wings that you see on the front bumper of cars. Now, they have a couple of different reasons. There's a couple of different outlooks on what they do and how they work, but generally they're called canards or dive planes. I've heard them called that as well. They essentially are going to add a little bit of extra downforce to the nose of the car, but they're only so good. They can only do so much, because when we talk about aerodynamics on a car, and this is by no means going to be an aerodynamics video, but when we talk about aerodynamics on a car, there's a lot of things that happen at the front end of a car. Depending on the shape of your car, this is an 84 Starion, so it's very boxy, but basically you have this sort of boundary area that goes down the side of the car, and the wheel spinning affects it, and there's all kinds of things that affect it. The openings for things like your radiator or intercooler. This case, I've got pop-up headlights, and again, it's very boxy. So they would be very minimal, just not having much of an effect on this car, but they might have more of an effect on other cars, depending on if you're using a front splitter and if the canard is part of the splitter and all that kind of stuff. But generally what we want to do is we'll see that we've got little wings, and they will be sort of on the bumper, or in my case, I've actually got a decent amount of fender here. They will be in that area. So with that said, what we're going to be doing is we're going to be talking about the process using both freeform modeling and surfacing, because there's a couple of reasons why we want to do that. But the main reason is that we're going to use freeform modeling to get the area where we want the canard, which is going to give us a surface that matches the car. And again, in this case, this car is very boxy, so it's going to be pretty easy. It's going to be harder in other cases, but the process will still work the same. The second thing that we want to do is we want to use surfacing techniques to actually build the shape of the canard. We're not going to be using complex sketches to do aero profiles on these things. Again, they are minimally effective, and generally you want to build them so that they can be adjusted and you can play around with how much downforce you actually get. What we're trying to do is we're trying to move the center of pressure, the overall aero on the car, closer to the center of gravity, or you want to position those in a way that it helps either load the front tires more for grip when you're steering, or load the rear more if you are accelerating, those kinds of things. So with all that said, let's go ahead and get started. So we're going to begin by creating a form, and I'm going to use the face form with the object snap option. Now I'm just going to build out an area where I want the canard to be, making sure it's just four-sided. I'm going to put it right about there, and I'm going to say OK. Pretty simple. In the bodies folder, we want to expand this and hide the mesh for right now. Then I'm going to take subdivide, and in this case, this is essentially flat, so exact versus simple doesn't really matter because we're going to pull it to the mesh. So you can use either, but you want to toggle on specify, and we're going to increase the number of divisions we have. Now, this is where the curvature that you're dealing with is going to come into play, and also the quality of your scan. So in this case, we are looking at a fairly flat car, so I don't really need 4x4 in terms of the width and length faces. But if you have a car with a lot of curvature, say you're dealing with a newer model car, maybe you've got a Lexus that is fairly flat in this area, then you'd probably be okay with this. But let's say you've got something from the 90s or 2000s, let's say it's an Evo bumper or an FD RX-7 bumper or something like that. There's going to be a lot more curvature in this area, and you likely need to bump this number up. So we're going to stick with 4x4 in this case, again, because it is fairly flat. I'm going to use Edit Form. I'm going to go to a front view, and I'm just going to move this out so it's away from the car. I'm going to go back to my side view, and with it still selected, I'm going to go to Modify, and we're going to go to Pull. Now this is going to take all the selected vertices. It's going to pull it down to the closest position on the mesh. We're using an auto option. Now, if you go to selected targets, it gets a bit tricky because then you're talking about the little triangles that are in here, and that's not what we want to do. You will also notice in this case there was some trim here that was removed. If you did follow that series, we removed and remeshed that area, which is why the density of the mesh is a bit different there. Again, but it doesn't matter because we're not going into that area and we're not manually selecting anything. But what we're doing is we're projecting the surface points, which is the smooth display, onto the mesh. We're going to say OK. And now what we should have if we finish the form is we should have a surface that is extremely close to the underlying mesh. And that's exactly what we want in terms of starting the Canard. The next thing I'm going to do is right click on the mesh and make it unselectable. So this way I'm not accidentally selecting the mesh when I'm using it. So that selectable, unselectable can help because then you're not accidentally grabbing that. It also does help with performance because anytime you hover over something, Fusion automatically wants to highlight it. And when you do that with a mesh, it really drags the performance down. So unless you have a really powerful computer, that can really be a drag on your modeling approach. So only have the mesh selectable when you need it. You can also turn off the edges, which can be done with the display. So visual style, Control and 4 will go to shaded. And you can change the color of this body if it helps. So we can right click on it and go to appearance, or you can hit A on the keyboard. And let's just give it a paint, a glossy paint. And I'm going to make it red just so it's a little bit easier to see. And you can see that that red is sort of marbled on the scan, which means that they're pretty close. You can also see a nice little dent that I have there. And even though we patched that area, that dent is still there. So with that red and with the edges hidden, I'm going to hit Control 6 to bring those back, and I'm going to hide this for now. The next step for us is to figure out the base shape of the Canard. Now, generally what you have is sort of a flat area that is going to be the mounting face. And depending on what you have underneath this, in this case it's on a metal fender, so it's going to be fairly rigid. You could screw it right to the fender. But depending on what you're mounting to, you might have to determine how big of an area you're working with. So for me, I'm not going to make it that big, but this is the area that we're working with. And it's on a metal fender. Again, in this case, it's not on the wide body, so pretty sturdy area. So we're going to start a sketch. I'm going to just use the right plane. And I'm going to take sort of a rough idea of where the wheel is. I don't necessarily need to do this, but this is going to help me with where the wheel is, where the wheel opening is, and just have that visual reference there. I'm also going to add a visual reference. I'm just going to add a horizontal line for where the bumper and the trim, sort of the body line is. And I'm going to add another one here to kind of give me an idea on where the air dam is on this car. So now if I hide the base mesh, I just kind of have these visual references there, so I don't need to keep that mesh visible for right now, just for this phase. I also have to consider how big this thing needs to be, how much it's going to sweep, and so on. I'm going to be using an arc for the base shape. It's just a 3-point arc. I'm going to start down here somewhere, come up into this corner, and that's going to be the base shape. In this video, I'm not going to go through adding dimensions to everything. It's something that you should do, especially if you're designing a part that you're going to be testing and you may want to make changes to. But for the purposes of this video, I'm not going to go through every dimension. What we're going to do is we're going to just build out the shape. So now that I have this, I'm going to take it and I'm going to offset it. And this is going to be the width of whatever mounting flange we have. I'm going to go ahead and just say 18 millimeters. We want to make sure that we're not extending past this. If we are, again, we can make some little tweaks. And I'll use the line tool, which is L on the keyboard. and finish that shape off and finish the sketch. So again, all the rest of that stuff was just kind of there as a visual reference. Not really needed, but it does help. So we're going to go to Surface, we'll go to Trim. Trim tool will be our sketch. We want to get rid of everything on the outside. And that leaves us with that little piece out in space. So I'm going to hide that sketch. I'm going to bring back the mesh. And now you can see this is sort of that base flange. We could start building our design off of this. Now, what often happens is you'll begin thickening this into a solid, but then it gets really complex in terms of how we can build this in 3D. So I'm not going to thicken this body just yet. There will be a point where we might do that. But for right now, I want to continue working with this as a surface. What I want to do to get started is I want to use Create Ruled Surface. I'm going to select this edge, turn off chain selection, and just select this top edge. And we can pull this out normal to the curvature, or we can pull it out toward a direction reference. Either of these will be fine. In this case, my direction reference is going to be that right plane. And I'm going to begin pulling this out. Now, the reason I'm doing this is because I want this to be horizontal at this point. Now, you'll notice that that arc is probably scooping up a little bit too much. I'm going to go back in and fix that. But this is going to be sort of the starting point before it begins to arc or flare up. So I want to have this reference in place. I'm going to say, okay. I'm going to show that sketch. I'm going to go back to a side view. And the reason I want to show the sketch is because the sketch itself is underdefined, which means that I can come in here and I can manipulate it and move it as long as I don't get to a position where I've extended past the boundary of that surface. We should be okay. So basically I want to play around with the shape and I want to make sure that at least the front edge isn't scooping up. Now, if you're having difficulties, it might be a good idea to actually edit the sketch and maybe use some sketch constraints like fix to lock a position on the sketch. And the reason I say that is because when we do leave things underdefined, oftentimes it can be difficult for us to go back and make those changes. So I'm going to use fix unfix on this front point. I'm going to hit escape. I'm going to grab a line, which I'll make horizontal. It says parallel, we want to delete that. I'm going to use horizontal, and then I want to convert it to construction. Now the reason I want to use this is because now I can add a tangency reference, and that'll make sure that that leading edge of our new surface is going to be completely parallel to the ground plane, assuming the car's sitting level in the scan. And then you can, again, play around with these, play around with the radius of curvature, play around with their position. Just make sure that they are still within that boundary of that surface. And now you can see everything updated. So when we look at this from the front, we no longer get it to dip down and back up. We've got that straight transition. So this is a good starting point, but there's a lot more that we need to do. The next step of this, we could really do this with projected sketches, or we could do this with a 3D sketch. So what I'm going to do is I'm going to start by creating a 3D sketch. I'm going to create a new sketch, just pick a plane, doesn't really matter because we're going to convert it to a 3D sketch. And I want to start a spline, and I want to come off of this front edge and just sort of come up and out and say, okay. I'm going to do the same thing back here, sort of come up and out and say, okay. Then I'm going to add tangency between that and this edge here. Now you'll notice that when I try to do this, it's not bringing in these references. When you need a 3D reference, if it doesn't automatically come in, you can go to Project Include and include 3D geometry. That's important because we don't want to project it into our sketch because even though it's a 3D sketch, it'll consider it that a 2D reference. Then I can take this point, I can snap those, and you might want to snap them in place and then take a look at it from the top just to make sure. And you can see from the top, these are actually on a plane. So if I grab these, I can pull them in 3D and sort of put them where I need to. If you have any issues moving them, you can always use Move Copy, which is M on the keyboard. And I want that to come up and back a little bit. And then I want to do the same thing to this point. I want it to come up and back a little bit. Once I'm happy with their position from the front and from the side or the top, depending on how you're working on this, then we want to make sure that they are tangent with this, because this is going to be a smooth reference. The last thing that we want to do is add another spline. This time I want to go between these 2 points. I'm going to say OK. Then we're going to go to the right and we'll hit escape to get off of that. We want to activate these handles and use move copy. So move copy is going to allow us to actually adjust the handles. Now, if we just use move copy now, we have to move it a little bit before we can activate the handle. But we want to give it a little bit of curvature and then say OK. So we've built sort of the rest of this thing out in 3D. We can finish the sketch and we can use a loft. So we're going to loft from this edge to this profile. When you're using surface lofts, the profiles can be open and they can also be 3D curves. If you're doing this with solids, then you don't have the option for any 3D inputs. We also want to make sure that we use these guides, and we also want to make sure that we have at least a tangency influence with that initial ruled surface. We're going to say OK, and now we're starting to sort of build out that shape. Again, we want to look at it from the front, make sure that we're not obscuring anything. You can see that we've got a little bit more of a scoop near that edge, and it kind of flattens out here on the corner. Perfectly fine. If you want it to be more scooped on the corner, all we need to do is go back and edit that sketch. Now, because this is a 3D sketch, it's a little bit trickier. We can't just push and pull it in just the view on screen, but we can play around with these, remembering that we've got tangency influence on those splines, so we should have freedom to sort of move them around and play with the shape. Currently, we've got 3 surfaces. At any point in time, we can stitch these together. I'm going to go ahead and add all 3 of these together, and this should give us 1 surface. Now, at this point, we could just thicken this and be done, but a lot of times you'll note that the end of the canards will have a slightly different profile. It'll get a little bit thicker. Sometimes this is for a buffeting effect with the arrow. Sometimes it's for structure. Sometimes it's for looks. Kind of just depends. But in this case, we want to at least explore how to do that. So what I'm going to do is go to Create, Offset. I'm going to take the entire surface, and I'm going to begin offsetting it this way. I don't need 10 millimeters. I'm going to say 3 millimeters. That'll be the overall thickness of this, and then we'll hit Enter. Now, we could have also thickened this 3 millimeters and gotten the same result, but in this case, I want to continue to work with this as a surface. This will help me build out that end shape. So there's a couple of ways that we can do this. We can loft from one edge to the other, and we can build a guide. And again, we can do that in 3D. We can build a third rail, a third profile that we want to loft through, or we can try to sweep along this edge. Now, if our intent here is to keep the bottom smooth and then sort of bulge up the top, my suggestion is that we build that with 3D curves. And we're going to do that again by starting a sketch. Just pick a plane. I'm going to double click the mouse wheel. We're going to go to Project Include and Include 3D. We're going to grab the 2 front edges. We also want to grab the 2 back edges. And then we want to build out planes for the shape that we want. So I'm going to take a fit point spline. I'm going to start from the bottom. And when I'm trying to do this, it's trying to automatically do it over here because we're looking at it with a front view. If we rotate this slightly, it will let me snap to these points, which is what I want to do. I'm going to create a point out in space, snap back here, say OK. We'll do the same thing over here. We can always move, add, or remove spline points, but just to get started, we want some sort of reference. So I'm going to come and add tangency between the spline and this edge, the spline and this edge. We'll do the same thing back here. We always want to make sure that we have tangency or curvature continuity when we're building out rails or profiles for a loft, because it's going to dictate or drive how we can actually build those surfaces. We're going to hit Escape. I'm going to take this 3D point, hit M for Move Copy, and I want to activate its handle. So we need to select this handle and select the endpoint, and then I'm going to start to build this out a bit bigger. Right click to say OK, and then we'll do something similar on the front. I need to activate that handle. I'm going to select one of those points, hit M, and then again I want to sort of give it some sort of shape. So you can see it's a different shape on the front, it's transitioning to a different shape on the back, perfectly fine, and we can finish our sketch. So now we have to decide, do we want to use these edges of the surface as a guide rail or as a loft profile? And honestly, it probably doesn't really matter, but I'm going to be using the start and end as my profiles, and then I'm going to be using these as my rails. I want to still make sure that I am driving tangency, and if you have any issues here, it probably means that one of your splines doesn't have tangency. We're going to say OK, and I'll stitch these together and stitch the bottom one together and say OK. So you can see we built out sort of that custom shape on the end. It's a little bit wider at the front, tapers down at the back. We obviously could do a lot more work for that shape, but again, for the purposes of this video, it's not really worth spending a ton of time doing that. The next thing that we need to do is turn this into a solid. And in order to do that, we need to start building out these shapes. We can do this pretty quickly with Loft. I'm just going to go from one edge to the other, right click and OK. By default, it'll just be connected, which will give us a straight edge between those two offsets. Right click to repeat the loft. We can go from here to here. Right click and go to the 3 o'clock position for OK. Right click and repeat the loft. You'll notice that something interesting happened here. You can see that when we stitch these together, it sort of built out this extra little piece. If this happens to you, one thing that you can do is you can try to use split face. Trim won't work at this point. We're going to try to split this face, and we'll use this as our splitting tool, allowing it to extend out. And then we can zoom in and we can delete that little piece. Now, this is not ideal to have that little jog there. It's something that we would want to avoid. Typically, this happens when we offset or thicken something that is not connected, or the direction of the UV curves is a little bit different. We can fix this by creating a sketch. Again, it's going to be a 3D sketch, so it doesn't really matter what you select. But what we want to do is find that corner. Let's rotate this around. And we're going to create a line. Because I know that this edge here and this edge here should be fairly planar. They're not perfectly planar, but they should be fairly close. I can just create a straight line here. Say OK. And then use my surface patch tool. Now, patch needs a closed boundary to work. It has to have a complete closed boundary. We've got two edges here, and now we've got that sketch line. And that should give us a complete boundary. The other thing that we could do is use something like extend or ruled surface and then trim it back. Make sure that you do toggle off enable chaining. And if you want to, you can drive tangency from edge 2 just to make sure it is flat. And then we can stitch these together. Stitching them together every step of the way is not required. And honestly, it's generally not something you want to do. But in this case, it helps because it changes the color, and that way we just remind ourselves that things are connected. So now we're going to loft between these two. If you want, at the bottom, you can add this as a guide rail, but because that other loft went straight from one to the other, they should match anyways. And the last thing that I want to do is stitch all of these little pieces together. And on the other side, we'll need to do that as well. And once we have those, this should leave a boundary where we should be able to just patch it. Going to now enable chaining to make the selection a bit easier. And if you notice that you have a problem like this in a corner, so that's that corner that we extended there, so you can see it's a little bit off. That's something that we want to definitely trim. So I'm gonna handle that by going to, let's go to a top view. I'm going to create a sketch. This time I want to make sure I select a plane. I'm going to make this a 2D sketch. And I am just going to go like this. And what we're going to do is we're going to make a surface that we're going to use to cap off the end and also trim away some of this extra stuff. So we're going to extrude this. Just take it all the way through the surface. And now that can be a trim tool. So this will be my trim tool. I'll get rid of everything on the edge here. You might need to rotate around to make sure that you're getting the right selection. Right click to repeat. This time I'll use this body, trim everything on the outside. And now we should have a nice, clean piece to fill in that area. You can do that on the front as well. If there's an issue with this, you can see that here. So once again, I'm going to do a 2D sketch. I'm going to go to a top plane. And this has that little jog in it. Not super concerned about it, but again, I'm just going to create a spline. And we're going to go ahead and just trim that with that spline. So again, extrude, pull this down, and we'll use it as a trim tool. Now there's no mutual trim in Fusion, and what I mean by that is we have to have these multiple trim features in order to get rid of all these little pieces. There is a tool called Boundary Fill, which I've talked about before on this channel. That tool, it is possible for us to make all these selections and work with that tool, but it's a little bit tricky, and I don't think it's very helpful for us to cover in this video. So we're doing a little bit of extra work with all these trims and stitches, but that's okay. I'm going to stitch these together. Now, if everything here is now closed and watertight, what we should have is a solid body. So as soon as we hit OK, it's going to put all those together, and now you can see this is a solid. I'm going to go back to my solid tools. I'm going to add a fillet here. We would want a fairly large fillet, and that's 10 millimeters. We're going to remember that because this one we would want to be 12, because actually we would want it to be 13 because we made this 3 millimeters thick, and that'll keep a consistent wall thickness. With fillets, we can use the add selection set to add multiple fillets at the same time. A lot of times when you're working on these designs, it's a little bit easier to just add a new fillet feature, but you can certainly use that option. As long as those edges don't intersect, then generally it works okay. Let's see, 15 is probably a bit much. Let's drag this back to maybe 2.5, that'll be okay. And then lastly, you can add a small fillet, maybe 1.5 millimeters, if it'll support it. Usually when you get into complex shapes like this, you'll notice that you start to have issues getting those fillets to work. But in this case, we kept those curves fairly broad as they exited because we had tangency, so it works out okay. And the last thing that you would need to do is add some holes to attach this, or if you're going to epoxy it. In some cases, you find if you're 3D printing this to make a mold that you might end up doing those holes after the fact and just drilling them, but you certainly could do this as a 2D sketch. You can bring back the original. So if we go back to the original sketch, we can bring that the original profile back and use that for an offset curve, or we could use project. So we're going to project, include, project, and let's say bring this edge. And then we might want to offset it a little bit for wherever we want the holes. I'm going to say 2.25 and just do a circle here, say 4 millimeters. And in this case, we don't have a pattern on a path. We just have rectangular and circular patterns. So if you want to do this at the sketch level, then what you end up having to do is drawing all those circles. If you want to do it at the pattern feature level, what we can do is extrude, which is E on the keyboard. We're going to take these profiles and we just want to extrude it through all. And then we can take a pattern on path. We'll take a feature, which is going to be that hole. And the path, we're going to use the edge on our part. And then we'll just start to drag this. Now, this will get a little tricky because you can see that it's not perfectly aligned. So what we're going to do is path direction, and we're going to increase the number, and we'll go all the way to the end here. So again, it's not going to be perfect because this edge doesn't stay centered because the fillet changes as it goes. So this might not be the best option for where those holes are. But again, you can kind of get an idea that this is going to allow us to put those holes in there. And that is pretty much it. So I'm going to bring back car. I made this huge. It's a bit exaggerated just for the purposes of the video, obviously. But with everything that we did, we can go back and make tweaks and changes to those sketches, pull it in a bit tighter to the car, and figure out exactly where we want this. Now, we left a lot of things underdefined, and those underdefined references are helpful when you're designing a part, when you're just sort of feeling out the shapes. But again, it is important that you go back and you make fully defined sketches whenever you're trying to design something for production, for example, or if you want to make tweaks or changes based on testing. So those are all things that are important. So that's pretty much all we're going to cover here. I am going to take a second to try to make some tweaks to these sketches and see if it works. Probably going to regret that decision, but I'm going to give it a shot with sketch 2. I'm going to make an edit, and I'm going to box select these 2 points, use M, and I'm going to pull them back in to get that a little bit closer. And then I am going to take this point here, just this one here. I'm going to use M. Let's see. Oh, geez. Let's finish that sketch. And let's see how bad this gets messed up. Now, so we're going to roll back the timeline. And we need to take a look at the next sketch. So here, the next sketch, sketch 3, again, because it's underdefined, we need to bring this back in line. So M to move that point. And this is where adding some dimensions would be helpful, because you can add a dimension that keeps this point a specific distance away from the rest of the geometry. Let me go ahead and say that. And now that loft should be a bit better. So fingers crossed, roll all the way to the end, see if it updates, and of course it doesn't, but that's okay. We can just make some tweaks and some changes. So I'm going to bring back my edges, Control 6, and it looks like probably some issues with stitching things together. Oftentimes when you make changes, then things where a body selection is required, things like a stitch, will oftentimes have issues. I don't really care about those because we ended up doing some extrudes and trims. So if we roll back just a little bit, that first one you can see, so there's the first problem, is I need to move this point. And that should fix that extrude, which should fix the trims, which should, well, it didn't fix it. So we want to get rid of the outside. Let's come back here. So we got rid of that part okay. Next one, we want to clear the selection. The trim tool is here, and we want to remove the outside. And now we can stitch them together. All right, so you can see that took a little bit of work. This edge looks like it'd probably be okay. So we're going to let that one update on its own. And see if the extrude is fine, if the trim is fine. And you can see here it's flip-flopping the selection. So we want to make sure that we double check which section is being which section is being trimmed. I'm going to stitch those together. That's fine. So now we have a solid. And then we're going to add some fillets. Those are all fine. These fillets hopefully will now fix themselves. That last one is going to have a problem in this inside corner probably. And let's see. Now we've got that. And then these are the holes. That's all good. So there you go. With a little bit of extra work, we're able to shorten that up. And of course, we just built one, but you could build as many as you want. We could take this and we could move a copy of it up. Now, of course, the copy isn't going to exactly match the body because we only sort of made that offset for the one. But this car is fairly flat. It is going to be fairly close, so I can just fake it for this video. And let's go ahead and move back. And there you go. So I know that was a little bit of roundabout. I didn't pre-design this part. I just went into this video and designed it on the fly. So these are the steps that I would go when I'm trying to build out a new shape like this. I didn't have any sketches or sort of images of what I wanted this to look like. We just started with the freeform. So now that we have shortened that thing up a little bit, Let's take a step back and let's also do this with freeform modeling. I want to at least give you an idea of how we can do this quickly and easily with forms, because it can be done both ways and there are pros and cons to each. So let's go ahead and let's create just a simple canard using the freeform modeling rather than doing it as a solid. Now, I think that there are some inherent benefits to doing this as a surface body because you can play around with some of the shapes a little bit easier. But for example, I can come in and I can start a freeform body. I can select the end here and insert an edge, which will put it right in the middle. And then I can take that edge and using edit form, I can start to build out the initial shape. Now, once I'm happy with the initial shape, if I want to make it a little bit wider at the back, maybe pull this in, I can then box select all the points and go through the same exact process of pulling that to the mesh. And once I have that, then once again, using edit form, we are going to use Alt on the keyboard to begin extruding. I'm going to let go of Alt and do it again because we want to keep that curve. Let go of Alt and do it again. Keep that curve. And this could be the basic way to build that canard shape. One option that we do have, which is pretty nice in freeform modeling, is to thicken in here. So I'm going to do -3 millimeters, the same that we did before. Then I'm going to take this edge. We're going to use insert edge. I'm going to stick it here near the end. This is a simple insertion mode, which is fine for what we're doing here. I'm going to take these two tops, right click, go into edit form. And from the front, what I want to do is start to build out that end shape. I'll say OK. I double click this top once more, insert edge, maybe pull that in a little bit. And so there you go. We can use the same methodology, and that only took a minute or two. And we built out a part. We can add a fillet to the bottom because now we have a solid body. Anywhere there was a crease or a sharp edge, we can also create a thicken with a smooth transition on the edges so it's nice and rounded. You just need to add enough detail that works for your specific model. So I'm going to add a fillet there. I'm going to do a minimal fillet on the front and back as well, maybe 1 millimeter. For whatever reason, it's taken quite a long time to figure these out, probably just because of the complex shape. I'm going to hide that, probably not helping. And we'll try to do 1 millimeter and see if I crash this. And we'll add one to the back. Does not like the one on the back as much, but that's okay. And there we go. So I will let you decide which process is quicker or easier. I like using freeform modeling for most things. It's quick, it's easy. But if you need to drive a specific shape, so if you're using a specific arc radius, for example, and you want to play around with how that radius affects the downforce, we don't really have that option when using freeform modeling. That's something that you will need to use traditional sketches and surfaces to create. However, if you're playing around with complex shapes and maybe you're taking this into a simulation study and you're playing around with how those shapes affect it, you can do this quite a bit quicker with freeform modeling than doing the traditional surface modeling. So just keep that in mind. There are multiple workflows and multiple ways that you can do this. Each of them have some benefits. There are pros and cons to each. Once again, freeform is a bit quicker, gives you a little bit more flexibility on the initial shape creation. The traditional method of sketches and surfaces will give you more control over the actual shape of those surfaces. So downstream, things like calculating downforce based on the radius that you have and how that relates to the size of the tire and the wheel opening, all that stuff, you will need those traditional features. So if you have any questions on this, please let me know. As always, thanks for watching, and we'll see you in the next one.